circuit like this, these are resistors. Okay, this is a battery here, 12-volt source. These are different resistors. Is this one wired in series or parallel? Parallel. Okay. So, what would be the voltage of each of these things if you measure them with an ohm meter or a voltmeter? If this was 12 volts, they would be equal, so they'd all be 12, according to Matthews. Do people agree with that? Does anybody disagree with that? You're right, Matthew. Good job. Woo, excellent. Okay, so what if we drew something like this on it? Let me put my eraser. Oh, there it is. Sorry, put it over here. Okay, in electrical drawing, what if I had something like this? What would that indicate?
Switch.
A switch. So would the current be flowing right now? Because the switch is open, right? If the switch was drawn like this, then what would happen? The current would be flowing. Okay? So let me know questions like that on the test. Those are really simple basics like this. Pardon? No, this one's in parallel. Okay, so anyways, so what is the potential difference measured in? What type of SI unit is potential difference measured in? Volts? Yeah, so volts are basically how much, say this was the positive pole over here. This is the negative pole of the battery. How fast or how much the potential difference in electricity is, 12 volts from here to get back to here. That is voltage. So 12 volts. So that is, volts are always going to be what we call the potential difference, or how fast the electrons are going to flow, and you measure that flow in I or currents. Okay? So there's questions on referring to that on the test too. Okay? So if the electrical force between two charges is increased when the distance is half as far apart. Okay, so if you had a power source and you made the wire half as long, what would that do to current?
Yes.
Well, no, I said, maybe you didn't hear what I said. But I said if you had a power source, like a battery down here, okay? And you had a wire going to a light bulb. That's just how they schematically draw light bulbs. And you made the wire half as long, what would it do to the power? How much faster would it increase? It would quadruple, is that what you said? You mean 4 times. Okay, correct. Correct answer. You remember that from the worksheets, right?
Yep.
Good job. Because that's on the test. Something about that on the test. Okay, so then there's a whole bunch of questions on Ohm's law, and you guys already worked on those. Today you guys are going to get an expert, you were working on this, that was great. So, what is a conductor?
That thing that attracts electricity.
It attracts electricity?
It controls, manipulates.
Yeah, and also electricity to go through.
Absorb.
So a conductor is something that allows electricity to flow through it. It'll flow through. What's an example of a conductor?
Wire.
Iron.
Copper.
Copper, like copper wire, okay.
Wrong.
What's an insulator?
Fast.
Something that's not well, conductor.
So if you were looking at the periodic chart up here, the periodic table, what would you call the things on this side? What are these called?
Semiconductor.
These are semiconductors here.
No.
What are these called over here?
Of the light metal.
They're called metals.
Metal.
What are these called over here? Non-metals.
Non-metals.
What's the thing in the diagram they're called? Semiconductors or metalloids. You guys forget that already? So would these be considered good conductors of electricity on the left side of the periodic chart?
No.
So metals are not good conductors of electricity. How many agree that metals are not good conductors? Deepar,
Yes.
do you agree that metals are not good conductors of electricity?
No.
Do you agree?
Yes.
Do you agree that metals are not good conductors of electricity?
You are good.
So you agree that they are not good.
They are.
They are. So you disagree, right?
Okay. Yeah.
So these are metals. Metals are good conductors of electricity. Non-metals are not good conductors. What's in between metals and non-metals? Semiconductors. Angela, what is an example of a semiconductor that they use in forming computer chips? Silicon. And why do they use silicon in computer chips?
It's very easy.
And then
It's cheap.
the
It's cheap, it comes from sand, but, okay, I'm sorry, what?
What is this?
No, go ahead, you were finishing, I'm sorry, go ahead.
like
What is the, yeah, so what is the ability that a semiconductor has, the property that it has, that makes it good in making computers and computer chips? The word semiconductor is actually explaining the property. So you're not sure? Rachel, do you know? Vicky, you know? Okay, does anybody know why they use semiconductors?
Because
Yes?
it's because it's already changed.
Okay, no. Does anybody know? Gary?
So that there aren't surges like electricity flow to the other parts of the computer.
So you're on the right path. So the thing is about semiconductors is you can convert them into making it highly conductive or non-conductive. You can change their property. So because of that, they work well as turning things on and off in a computer. Because in a computer, you're constantly turning it on and off and opening different apps and different windows. Okay? Let's bring it in. Pay attention to what we're talking about. Because there's questions on this on the test. Okay? Okay, so Jason, okay, what do we measure? What is I?
Current.
Okay, how do we measure current?
X.
Using the triangle method.
X.
Okay,
P divided by D.
okay, so girls,
Still be respectful.
you're not going on the phone for me, okay? So what is charging by contact? Jason,
What?
what is charging by contact?
It charges.
It charges.
Okay. You guys remember I did some kind of experiment with a balloon?
Yes. Anything moves to. Yes.
So how was I able to make the balloon attract to the paper?
You transfer your electrons to your other electricity.
You transfer electricity from it.
So I rubbed the balloon on the hair and it made the balloon, which is a non-conductor, pick up electrical charge.
Yes.
So what did it do to the paper? Why was the paper attracted to it?
Positive charge.
So how did it get a positive charge? Yes. Transfer, what do you mean transfer? So when I put the balloon close to the paper, the electrons in the paper moved to the other side of the paper. So it left the one side of the paper close to the balloon relatively positively charged. Now, a positive and negative charge causes attraction, that's why paper will do. So you'll need to explain that on the test.
Yes.
Okay? Okay, that's really it. Everything else is pretty simple. It's a pretty short test. I think you guys are gonna do well.
How many questions?
1,000.
There's like 27.
Yeah. 1,000.